All right, good morning. Welcome back to Calculus 2. So we are looking at the series n equals 1 to infinity of 5n plus 5 all over 8n plus 5. And plus 3, rather. Let me go ahead and double check that. Yeah, 8n plus 3. Let's go ahead and write down the right problem. Okay, here we go. 8n plus 3, all raised to the nth power. Okay, um, we either use the ratio test or we can use the root test. In this case, the ratio test isn't going to help too much because we're going to have a bunch of n plus ones all over the place, which is usually very nice. With factorials, that's exactly what you want. However, in this case, if I take the limit, the thing that's really the problem right here is that we have kind of like, we're going to get an infinity over infinity raised to the infinity power, and it seems like kind of a mess. So I think what we're going to do with this one is we're going to attempt the root test. Okay. And the way the root test works is we're going to take the nth root of what's going on here. So we're going to take, okay, this is 5n plus 5, all raised to the 8n plus 3. We actually need the absolute value of this. Okay, well, actually, yeah. Raised to the nth power here. And the thing that's going to happen with this is this n, it's the root and the n that's to the power are going to cancel each other out. And then we're going to have to take our limit. So we're going to find out the limit of the a n's. If this is greater than 1, then we're going to diverge. Okay. If the limit of your a sub n's, okay, is equal to 1, then we have an indeterminate test. The test fails. We don't get any information out of it. Okay. So we have no information. You have to use a different test or a different method. Okay. Or perhaps the limit, if a sub n is less than 1, then we know that the series converges, and it converts, since we have to use absolute value, it converges absolutely. So we converge absolutely here. Okay, which just means the absolute value of this thing converges, and that's most of what we care about. Okay, so that's what we're dealing with. Okay, so here we go with what's going on here. So as I go ahead and take my limit, my root test here, we actually end up with the n to the power and the n's cancel. That's kind of the whole point. So we have a 5n over 5, 8n plus 3. We saw the summation here. We're still dealing with absolute values. What we want to do is we want to take our limit as n goes off to infinity to see what happens. Now, I don't really need the absolute values here because we have n is greater than 1, greater than or equal to 1. So these are all going to be positive numbers. But the important thing about this is we're going to go ahead and just take this limit. And you could use L'Hopital's. I don't think you need L'Hopital's for this case because we can go back to calculus 1 at the beginning, multiply both of these pieces by 1 over n over 1 over n, and we're going to get 5 plus 5 over n divided by 8 plus 3 over n. And as we take our limit, as n goes off to infinity, then we're pretty much going to end up with a 5 over 8. And then we could say plus 0 plus 0. Okay. Just put in quotes there saying I've taken the limit. So these pieces are going to go away. So we just end up with a value of 5/8. Okay. 5/8 is less than 1. So we have this series converges. And we also say converges absolutely. Okay, because we technically had to put those in the absolute value, even though we know we're all positive, so it's going to be okay. But we converge absolutely for this series. Okay, so that's how you deal with the root test. If you have factorials, you definitely want to use the ratio test. The ratio test is probably more useful than the root test. The root test is nice when you have situations like this, but uh, it's more difficult to like, the use of the root test is a little bit more limited. The ratio test is a little bit easier to go deal with. Okay, so usually if you wouldn't, if you're like, I don't know, you're going to guess ratio test, but there are times when the root test is actually your way to go. Okay. Thank you very much for watching the video. I'll see you in the next one and take care until then.